Leaving Cert 2024, question number 7. This is a question on projectiles, and it's from lesson 3, where we're going to find the angles, which is probably the hardest question of all. So in part A, we're going to do question 7, part A. Fiona plays camogie and wishes to improve her accuracy in scoring points. She stands at P, which is 35 meters in front of the goal line, and strikes a schlitter with an initial velocity of 20 meters per second at an angle alpha to the horizontal ground. So in order to successfully score a point, the schlitter must pass over the crossbar, which is 2.5 meters above the ground, as shown in the diagram. You in part 1 have to derive an expression in terms of alpha for the time taken for the schlitter to reach the goal line. Right, so let's have a look at this in detail on the board. So here's the diagram. So the schlitter is given an initial velocity of 20 meters per second at an angle alpha. We'll have to find that angle alpha later on. And it's going to go through, and it's got to at least hit the crossbar. We want it to go over the crossbar, which is at a height of 2.5 meters above the ground. The goalposts are 35 meters away from P, where Fiona stands. And what they're asking me to do in part 1 is to find the time, an expression for the time to reach the goal line. Well, what do we always start off doing? We do our table. There's my table there. UX, AX, SX, and the same in the Y direction. So what's UX? UX is 20 cos alpha. UI is 20 sine alpha. So you're well used to that at this stage. AX is always 0. AY is always minus 9.8. What's the distance travelled in the X direction to arrive at the goalpost? 35. And what is the height it has to go above the ground to reach the goalpost? 2.5. So this is 35 and 2.5. So there's a table for reaching the crossbar. Now, if we're doing a question like this, what do we always start off doing? We always start on the left-hand side because we have the same amount of information in each side. But remember, when I write down my equation, S equals UT plus a half AT squared, and I apply that in the X direction, that last term disappears. So it's a much easier equation. So Sx is equal to Uxt. That term is gone. So now what's Sx? 35. And that's equal to Ux, which is 20 cos alpha, multiplied by T. And they want you to find an expression for time. Well, time is equal to 35 divided by 20 cos alpha. And you're going to put that then into the equation for Sy, and that's how you're going to find the angles alpha later on. No need to tidy that up. As I said, lots of stuff cancels if you leave it like that. So there's an expression for the time, and there's 5 marks to do that. So what's the next part of the question? Well, as you can guess, the next part of the question will be, I'm going to find the angles. See the amount of space they gave me to do that little part? Sometimes you can be fooled. I mean, it literally took me a couple of lines to do that first part, and yet I see all this space here. So I might be thinking to myself, hang on, there must be more work to do. So don't get fazed by that. Anyway, let's get on to part 2. So part 2 asks the question, calculate the values of alpha. So there are 2 values of alpha, such that the schlitter hits the crossbar. So we wanted to hit the crossbar, so we know that Sy is exactly 2.5. So I'm going to take that time there. I'm going to move it on to the next board, and I'm going to write down that equation in terms of Y. So here's part 2. The time I've worked out to be 35 over 20 cos alpha. And I'm now going to write down my SY equation. So SY is equal to UIT plus a half AY T squared. So I'm now going to fit in the numbers. So just remind myself what the numbers are again in the Y direction. UY is 20 sine alpha. AY is minus 9.8. And SY is plus 2.5. So I'm now going to put them in here. So 2.5 is equal to 20 sine alpha by time, which I'm going to take from part 1. So it's 35 over 20 cos alpha. Plus a half AY, you know that well, don't you? It's half of minus 9.8, which gives me minus 4.9. T squared is 35 all over 20 cos alpha all squared. Now, we've done so many examples of this. You're well used to working this out. You're going to turn everything into tan. The two parts of tan that I'm going to use, I know that tan A is sine A over cos A. So we're going to apply that to the first part here. So now my next line is 2.5 is equal to, the 20s cancel. Sine alpha over cos alpha, that's tan alpha. So I have 35 tan alpha. And the next part is a little bit trickier. I'm going to end up with 1 over cos squared, 1 over cos squared A from the table book. It's actually sec squared in the table book, so be aware of that. But that's equal to 1 plus tan squared A. That's the other one I'm going to use. So write down the minus. First thing I want you to do is do all the numbers on your calculator. See what you end up getting. So I'm going to multiply 4.9 multiplied by brackets 35 over 20 close bracket squared. And I get, let me write down the entire number. I get 15.00625, and that's over cos squared alpha there. Now 1 over cos squared A is 1 plus tan squared A. So that's how I'm going to turn that into tan. So my next line becomes 2.5 is equal to 35 tan alpha minus 15.00625. And the cos squared alpha becomes 1 plus tan squared alpha. Now multiply those brackets out. Then bring all terms to the left-hand side, so you have a quadratic in tan. So bring that across. So I get plus 15.00625 tan squared alpha. Bring across the tan alpha, minus 35 tan alpha. And bring the numbers across. So that becomes plus 15.00625 added to 2.5 will give me plus 17.50625. And that's all equal to 0. So now I've got a quadratic in tan. So there are the two identities right here that you have to use. So now let's apply the formula to find tan alpha. So I'm going to get tan alpha is equal to, so you're going to apply your minus b plus or minus the square root of b squared minus 4ac all over 2a. There's your a, value of a. There's your value of b. And there's your value of c. Those numbers there. We'll put them in. The tan alpha is minus b, which is plus 35, plus or minus the square root of b squared That's minus 35 squared. Minus 4 times A, 15.00625 by C, which is 17.50625. And that's all over 2 times A. Two times 15.00625. So put that into your calculator, and that will give me my two values of tan alpha. So I have tan alpha is equal to, let's put the minus 1 in first. That'll be the smaller angle. So in my calculator, fraction 35 minus the square root of, you don't need to put the minus in because when you square it, you're going to get plus 35 squared minus 4 times A, 15.00625 by C, 17.50625 all over 2 times A, which is 15.00625. So that's equal to, I'm going to get an answer of, let's go to lots of decimals, let's go to 4. I'm going to get an answer of 0.7264. That's one answer. And the other answer for tan alpha, well, no need to put the whole thing in again. Press the replay button on your calculator or whatever button is required. Delete the minus, change that to a plus, and I end up with 1.6059. So now to get alpha, get the inverse tans of each of those. So shift tan, 0.7264. And that gives me an answer of 35.99, well, just about 36 degrees. That's one angle. And then input the other one. The inverse tan of 1.6059. And I get an answer of, say, 58.1 degrees. So that's a very standard procedure. So if you get that in an exam, great, because you know exactly what to do.